For the important variables, say for the exposure of your interest or the outcome of your interest or the most important covariates, you might like to dig deeper. You want to know more about that particular variable or a number of those variables which you will be including into your study, into your analysis. You can use distribution analysis by point and click method to learn more about any of the variable or continuous variable, or by coding we use the code Proc Univariate. Let's do that. Okay, go to task and utilities. Under tasks, under statistics, double click on distribution analysis. Okay, under data tab we have FHS underscore lib.heart already selected. Let our analysis variable be age chronic heart disease diagnosed. Maybe our research question is related to, say, how age at which chronic heart disease diagnosed is affected by some other factors. In that case, our outcome of interest will be the age at which the people are developing chronic heart disease. So let's dig deeper into this particular variable. Okay. Now on the options tab, I'm gonna leave all of them as such. Yeah, that's the problem. We have to remove the histogram manually. So for to do that, go to this edit button and then just manually remove histogram and just submit this code. Okay, so here is the detailed information about that particular variable. If I can make it bigger, we have the mean age at which chronic heart disease is diagnosed, that we will also get through the proc means step also, but or the summary statistic, but we'll see in the later table that it is giving us way more information by this function. Okay, standard deviation is 10, and then we see here it is providing us by the quintiles. Okay, the median is 63, so and the first percentile is 39, and 99 percentile is 86. Okay, so what are percentile? You might already know, but it is worth it if we just repeat what percentile are. So if we take, for example, diastolic blood pressure, let's take age chronic heart disease because that's where we are working on. Okay. I'm just gonna copy it. I'm gonna open a new spreadsheet. I'm gonna paste it there, and now I'm going to sort them out from smallest to largest. Okay, let this be the header so it doesn't move down. Okay. And now I'm going to sort them from A to Z. It is not taking, okay, problem. Okay, now it should work. Okay, the smallest age at the number here is 32, indicating that it is the youngest age a person is developing chronic heart disease in our cohort. And then we see that the oldest age at which chronic heart disease is being diagnosed is 90, as we understand. So the percentile is that we divide all these numbers. These are 1450. So each percentile will be 1450 divided by 100, which is 145. So first percentile will be 14.5. So every 14th value will be a new percentile, in fact 14.5. So 39 is the first percentile, and then it should be 29th value, which is the second percentile. So we are dividing all these values into 100 groups, and the topmost value from each group will be the value for that percentile. First percentile is here, second percentile is here, and the middle value, which will be 1450 divided by 2, becomes what, 725th. 725th value will be the median value. 725th value, when the values are all sorted out from smallest to largest, the middle value will be median. So as we have learned it many times before, 725th value right here. So 63 is the median. Okay, and the maximum value, of course, is the last value. Okay, so coming back to our SAS results, we see that the median is 63 as we manually calculated or determined, and the first percentile is 39 as we manually determined, and same goes for fifth percentile, which will be the 5 times 14.5. so whatever that value comes down to, if we go down to that value, we will find that it is 47 on 47, and so on. Okay.